Good morning, FOR 242. Today we are going to select cells from the Enhanced Forest Inventory that fall within a certain distance of roads that are within our property that happen to be in good condition. You will need the data from last week called Lab Area, Roads, and EFI. I'm going to uncheck EFI for now, leaving only the boundary of our property, which is of course fictitious, and the roads. And remember, these roads are category 9. They're no good, they're not passable, they go through swamps that have taken the road with them many years ago, so we need to get rid of them eventually. But for our first step, we need to clip the roads layer to the property so we have only the roads that fall within our jurisdiction here. That's one of the most commonly used tools. It's called Clip and is available under Vector, Geoprocessing Tools, Clip. In this case, the tool has defaulted to use the input layer I have selected here. If it has not, I can use the drop down here and choose which one I want to select or clip from. And then I need an overlay layer, which in this case is going to be Lab Area. So think of this as sort of cookie dough rolled out on the counter, and this is a cookie cutter. You can create a temporary layer, which is my preference, or you can use these three dots here to save this in someplace that's safe. Your Google Drive file stream, but absolutely not the C drive on the lab computer. That gets wiped every time you log off. When that's done, you have the input layer, roads, overlay layer, lab area, run. Close. Uncheck roads, and see now we just have the roads that we own. And you see it has cut off here. So this road starts within our property and ends outside of it and then comes back in, and that's going to affect our analysis. That's actually a good time to learn how to make some simple edits. So let's uncheck Lab Area. We need to connect point A to point B. That's our road. It's just a little geospatial error that's led to that not connecting. We need to be able to select features within a distance of the road that we know exists. So what we're going to do is right-click on Clipped and toggle editing. Now this button here was grayed out before because when you're not editing you can't do this, but now select this tool and whatever you do next is going to work with that tool. And now if I hover over that, I can just go ahead and click once to start, click once to set the next vertex, and right click to finish. And I could give it all sorts of information if I wanted to, but for the time being, we don't need to do that. So, okay. And let's go ahead and zoom in on this, and you see how that's missed a little bit. That's not the best. So, what I can do is use the vertex tool here, which I can use, select this one, and click once to grab it, and then I can go ahead and connect that. That's still imperfect. I can keep on going to the point of ridiculousness, but at this point we are zoomed in at a scale of 16 to 1, and that's, well, the road's all the way out here, so we're fine. We can then zoom in on the other end of this, make sure this is at least pretty good, and pop that in there. If we really want to, we can make that as close to perfect as possible. So that's that done. And now I can right click on that and toggle editing, save the edits. So now these are grayed out again. Right click on Clipped, zoom to layer at the top here, and there's our road that connects as it should. Now I'm going to right click on Clipped again, toggle editing back on, I need that on again, right click and open the attribute table. And see how we have these codes here, F4, 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 F9. F9 is the one that's an old road that in practical purposes is no longer usable. We want to delete all of those from this data set. We don't even want to think about them. They're not part of this problem. So what I'm going to do is write a query that selects anything where the code is F9, and then I'm going to delete all of those. So the query is going to select, meaning highlight them. And once they're highlighted, I can just go ahead and hit the delete key and they go away. So select features using an expression. I have to start typing in code, there we go, equals F F9. But see how it's saying expression is invalid. This is text, and it needs to be in single quotation marks. So it just went from not valid to 0. Now we can go ahead and select features, and anything F9 is now selected. I can now close this, go ahead and hit my delete key, not the backspace. Or if that's different on a Mac, the trash can does what it says on the tin. Delete selected features. Goodbye. That leaves only category 4 roads, and this one with no data, which is the one we just created. So I'm going to close that, and now we can turn lab area back on, right click on clipped, toggle editing, save, and compare to the old. So that's the entire road system there, and that is what's left when we're asking only for the good usable roads. Let's go ahead and change the symbology on that, so I can double click on that color swatch here. Let's go ahead and make that a nice red like we had before. Make that a bit thicker, change the width to 0.66, okay. And let's go ahead and put the roads above the lab area, and that shows, according to, of course, the drawing order here is the same as the drawing order here. So the lab area had been obscuring that part of the road. Moving that up above brings it back into view. Now we need to go ahead and ask the question, which areas of this property are within or without a reasonable skidding distance? Skidding meaning the going out and retrieving of wood that has been cut using a skidder. Or forwarding, going out and retrieving wood that has been cut down and cut to log length using a forwarder. In any case, we'll use the distance 1,250 feet as the longest you would want to skid or forward before it makes more sense to build a road to get to that location. Those machines have a lot of torque, they can move a lot of wood, but they don't go very fast. So, let's go ahead under Vector, Geoprocessing Tools, Buffer. Our input layer has got to be set to clipped, what I've called my new roads that are within the property and category 4 or better. And the distance units needs to be set to feet. And then I can change the distance to 1,250. And I'm going to check dissolve result. What that's going to do is if two buffers overlap, those are just going to get blended together. I don't care which road it's within 1,250 feet of, I just care if it is or if it isn't. And as always, we can create a temporary layer or give it a place to land as a permanent file. Run. And close. Now you'll notice this has a lot of area that's outside of our actual property. So let's go ahead and get rid of that by Vector, Geoprocessing Tools, Clip. Our input layer is going to be buffered, and our overlay layer is going to be lab area. And I'm going to go ahead and run, and there is our new layer that shows only the areas within the property that are within 1,250 feet of a road. As always, I can go ahead and change the symbology here by double-clicking on the color swatch. Click on Simple Fill to give these options here. Fill style, no brush. Stroke color, let's go ahead and make that an interesting shade of orange, make that a bit thicker, but instead of a solid line, let's go for a dotted line. Apply, how does that look? That looks fine, okay. So now we can see this area here and these areas down here are outside of a reasonable skidding distance. And of course the question is, do we care? So let's go ahead and scroll all the way down here to where we have our XYZ tiles. Google Satellite Imagery, which you've used before. If this doesn't pop up from where you made this connection before, go back to the video that has how to connect that and go ahead and pop that in. Okay, and there we are, but that's too high in our drawing order. Go ahead and drop that down to the bottom. There we go. So here we have some pros and some cons. If we wanted to get anywhere in here, it wouldn't make sense to haul across this because this has recently been harvested. It's in a regenerating condition. We don't want to drive through the regeneration. Those young seedlings would be sensitive to being crushed. So that's not actually a reasonable skid. We'd have to go around, and that going around is going to be a greater distance. It doesn't matter much that we can't get to this because it's a swamp and you might sink the machine in it anyway, and it looks like there's some beaver dams in there. There is some conifer in there, so it's potentially of interest, but it's not really prime ground. So is it worth building a road to or not? That's a landowner priorities type decision and a on-the-ground investigation type call. But in any case, you can't get there from here. And this area in here is not accessible either, so that would be a candidate for a spur road if it was worthwhile to do it. How big is this area? We've got to know that. We can use our measuring tool here, use this drop down here to measure area, and we want the area in acres because that's usually what we're used to. Click once to start, once to make a turn, click, click, right click to finish. 12.5 acres. Is it worth building a road to access 12.5 acres? Maybe, maybe not. That depends on many things, but as always, GIS, Geographic Information Systems, is a decision support tool. It is meant to give you information, and in this case, the information is these 12.5 acres are outside of what we consider to be a reasonable skidding distance. Are there circumstances where you might go 1,300 feet? Sure. And there's also situations where a 500-foot skid would be much more difficult and onerous and wouldn't be a good idea. Imagine some physical obstacle here. But what we really want to know about is the EFI data outside of this area where we can't get to it. And that requires us to finally check our EFI on, and then what we can do is select by location. So we have vector, research tools, select by location. Select features from the EFI that intersect with our clipped polygon, not line. So you see how that's a line feature there. That's the clipped roads. We want the clipped polygon, which is the buffer around those roads. And modify current selection by creating a new selection. Go ahead and run. Close. And see how that's selected everything that is within that buffer. Well, we've got a nice little button there, and don't click it, but click the drop down here, and you can invert feature selection. And you see that didn't quite work as intended. That inverted the feature selection of the clipped roads, which I had selected here. So QGIS cares what you have selected over here, and since I had none of them selected, now I have all of them selected. So let's go ahead and select our EFI and hit that button again. Invert feature selection. That's done what I wanted to. So these are all the cells that are outside of that reasonable skidding distance. Let's go ahead and export those as their own layer. So right click on EFI, export, save feature as, and make sure you check save only selected features. And you can't just enter a file name here, you have to go to these three dots, and then we can go FOR 242 datasets, new folder, week 12, and double click here, and this is EFI outside skidding distance.shp. And you see I'm using underscores to connect all this. This is sort of habit. The shapefile, it will sometimes let you put a space in there. There are situations where it really makes a problem, so I always either just run it all together or use underscores. No spaces. Save. Now we have our coordinate reference system, NAD 83, UTM zone 19 north. We are saving only the selected features, and we are good to go. Okay, there we go. Uncheck EFI. And that's the result. And you see how this is different from clip. So this hasn't cut any of these cells. It's taken any cell that intersects this boundary here and selected it. Then we inverted that selection. So anything that's not touching that line is now in that new data set. Now let's get an idea of what we're looking at. So let's right click and go to Properties. And from there, into the Symbology tab, instead of single symbol, let's go ahead to Graduated and set the value to sawlog. Now we have to say classify, and these values are in cubic meters per hectare. Lower saw log volume, white. Higher saw log value, red. Okay. And there we go. So we have more saw log volume here, much less saw log volume here, more over here, less down here in the swamp, fair bit over here. This area and this area are within the 250-foot buffer on these ponds, so may or may not be of any interest at all. Given all the likely limitations here, let's just go ahead and get rid of this. So, right-click, toggle editing, select features using a polygon, make sure you have this selected over here. Click once to start. Every time you click, you make a turn. When you're done, click and then right-click. That's selected all of those. Go ahead and hit the trash can and those are gone. Now right-click, toggle editing, save, right-click, zoom to layer, use scroll wheel to zoom in, use the hand tool or the pan tool to move around. These are now the only areas within our consideration. We have the hardwood side and we have the softwood side. Uncheck here so you can see the air photo. All hardwood up here, softwood down here with a bit of mixed wood in here. So now what we're going to do is make a new feature for the new road and then ask the question, is it worthwhile? Does it pay for itself in the value of the timber recovered from a reasonable prescription? You may choose this one or that one or one of the other two areas that I deleted. You don't have to delete those. Let's say I want to reach these 12.5 acres of hardwood over here. First thing I need is a new lines shapefile. I'm going to go into my FOR 242 datasets, find week 12, right click on week 12, new shapefile. I'm going to change this name here to new road, if I can spell road, and geometry type has got to be line, and coordinate system should be UTM zone 19 north. And I'm going to make a new field called length, FT, feet, and add to fields list. I've made this a data type string, which is the default, and string means text. So when I keep this as text, what pops in is type string. That's just how computers refer to text, as string. So remember, string, text, text, string. Now, I don't want that, so I'm going to remove field here and try again. Length, FT, type instead of text, decimal number. Precision 6, okay. Add to fields list. Now, decimal number, real number, and integer is whole number, so no decimals allowed in integer. Now, that is all set, so we have a spot for it to land. That should be your Google Drive file stream, of course. Geometry type line, UTM zone 19 north, length feet, type real, precision 6. Okay. And now I can go into week 12, open that up, double click on new road, and there is my blank shape file. Now I'm going to right click and toggle editing, and I want to get to about the midpoint of this so that I can skid from each side, but I'm also going to be going through the middle of this and working on each side of my new road as we go. And this looks like a middle-aged to mature hardwood stand, so let's say we want to do a shelterwood operation and encourage regeneration of the same species, which looks like a mostly sugar maple and yellow birch. We have some poplar along the edges here. We prefer not to have that. That's a lower value weedy species that was never as abundant as it is now in the historical condition of Maine's forests, which we know from old survey records, old land records, and existing old growth forests. For my non-forestry students, and refresher for the forestry students, a shelterwood operation is intending to give just enough light for the shade-tolerant species that we want, which in this case is sugar maple and yellow birch, but not enough light that the shade-intolerant or light-demanding species like aspen or poplar can get established. So it's weed control by shade. So we need more context than just this. We need to have an elevation model and a hillshade. So let's go ahead and uncheck that. we have in here in the lab area hillshade. We can go ahead and check that on, and that looks like pretty easy ground to work with, so it might actually not matter tremendously. But let's go ahead and add the elevation model in there. Let's go ahead and symbolize that. Render type, single band pseudo color, and color ramp is going to be spectral, and apply there. See how that looks. Min-max value settings. I often like to change the statistics extent to the updated canvas. Apply, and now the highest value within view gets the red, and the lowest value gets the blue, but that's reversed. So let's go ahead under here, invert the color ramp. It's more intuitive for the low color to be blue and the red color to be high. Apply. There we go. Now that's making sense. Very good. And as a final step, the transparency, set that to about 50%. Apply, and now we have elevation tinted hillshade. Let's go ahead and hit OK on that. And that really doesn't look like we have any serious obstacles. We could go in a straight line if we wanted to be very angular about this, or we could go at a bit of an angle and follow the contour along there and do a sort of side slope road or a bench cut road, and that might help us with our drainage. I hope Professor Dubus is listening to this and appreciating my reaching into the depths of memory for a bench cut road. But in any case, none of this looks very steep. We can see the old road here, which we could actually follow along for a ways if we wanted to. If we wanted to just sort of bring that back into condition, that's actually not a bad idea. So let's just go ahead and say we're going to depart from here, fix up this old road. Don't know if it's going to need much. That would be a look and see on the ground. And then we're going to depart and go in here. We could also just repair this old road and then skid from here to here. That would now be within range. But let's say we desperately want to get in here and actually end the road in our unharvested, unreachable block here. And it does look like there's an area where the road is simply missing there. So let's go ahead to our new road. Editing is on. You see that pencil there. And now we need to go ahead and add a line feature. I'm going to zoom right in here so I can see where I'm starting. Click once to begin, then zoom out. I'm using my scroll wheel. And I'm just going to trace along here. Click, click, click. Every time I click, I make a new vertex or a new turn. And I'm doing my best to stay within the bounds of the old road. This is going to make my terrain profile look kind of funny, because of course it's going over an artificial feature here. But there's nothing in here that can't be easily dealt with the excavator and with the dozer there. So there's really nothing here besides maybe some rock outcroppings we'd have to look for on the ground. But in any case, that's got us pretty good and close. So let's just straight line it and end it right there. And I have to right click to finish that feature there. And I'm going to leave both of those as blanks. Okay, so there's my new road, following along there, and that's the end of it. And I want to know what the terrain profile of my new road is, because of course I do, and that's the terrain profile tool. You might have to reinstall that if you don't have it under plugins, manage and install plugins. You remember that from before. We need to go ahead and add our elevation model. And before this is going to work, we need to right-click on New Road, toggle the editing, and save the edits. Now, we need to have that selected over here and have our selection to be the selected layer. That's now selected, and we can see the change in elevation across the way there. And we can see over here, we're going from 275 feet up to a maximum of 278. And then we're leveling off here. Elevation change of 3 feet is well within construction. That's not a reroute the road, that's just level it out. So go ahead and screenshot that. That's one part of the assignment, and then close it out. Now we need to know how long this road is, and we're going to make the assumption that road building costs $5 per foot. Road building costs vary tremendously, and of course we're not building new road along a lot of this, so that's going to affect things. but we're just going to ballpark it at $5 per foot. So right-click on New Road, open the attribute table, and let's go ahead and use our open field calculator. And we are not creating a new field, we are updating an existing field, and we need to tell it which one to look at, and that is length feet. And we are going to go into this window here, type $length, and that, if we just were to hit OK, would give us the length in meters, because we are in UTM, Universal Transverse Mercator, UTM Zone 19 North. The units are in meters. So what we need to do is type in the asterisk and multiply by 3.28084 to convert from meters to feet. OK. And there's our length in feet, 1,582.33565. That length in feet times $5 per foot makes $7,911.68. So we have an $8,000 road, and that's assuming no culverts, no bridges, no other fun and games, but neglects the cost savings of going along an old road. Now the question becomes, is it worth it? So right-click and toggle the editing so that's all saved and good and done. And now let's go ahead and let's see, there's our EFI within or outside of skidding distance, which we are reaching, and all of this doesn't matter because it's already been harvested. Remember that from our air photo here. Can't cut what's already been cut, so that part's out. Only this part matters. So we can click upon our EFI outside of the skidding distance, select by Polygon, click, 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 to make sure we're selecting only that. Right-click to finish. So now we've got that bit selected. Right-click, export, save features as, save only the selected features. File name is going to be harvestnew.shp, and let's see, save only selected features, UTM 19 North. We are good to go. Okay. So let's go ahead and uncheck that and go ahead now, right-click on Harvest New, open the attribute table, and here are a variety of attributes. Among those attributes are values we calculated last time, and we have sawlog volume and cords of firewood if we only harvested that wood that was merchantable but not sawlog. Now we're concerned about the sawlog volume itself. If you don't have this from last week, go ahead and follow the instructions from there so you do. Since we have that, all we need to do here is go into our statistics tool here, point it at our harvest new, and then ask for the sawlog volume. And look to the sum, 451. So that's 451 cubic meters of sawlog, and that's going to be hardwood mixed sugar maple yellow birch. Now we can easily search for cubic meters to cubic feet. We want to go from cubic meters to board feet because that's the unit we have stumpage values for. So let's go ahead and type in our 451, and we have 15,926.9 cubic feet. And now we have a little issue with converting from cubic feet to board feet, and depending how you scale, whether you're looking at round wood versus just the conceptual 112 by 12 inch cubic foot, which doesn't really exist. When you're working with a log scale that's in board feet, that scale is accounting for the width of the saw, or the kerf. That's why you have 1/4 inch international log rule. That 1/4 inch is assuming a 1/4 inch kerf. But when you're looking at cubic feet, you're just asking what is the actual volume of this log. So a board foot log scale is asking what do I expect to get out of this if I saw it in a particular way, where a cubic foot scale is just asking what is the volume of wood inside of this log. Since we're in GIS class and not a forest mensuration class right now, let's just go ahead and leave that there, accepting that this conversion is not exactly perfect. So we had 1,000 515,926.9, and that gives us 191,122.7992 board feet. And of course, we buy and sell wood by the 1,000 board feet, and this precision is absurd, of course. So we have 191,000 board feet. So 191,122.7992 becomes 191 MBF, or 191,000 board feet. And now to the Maine Stumpage Report, annual reports and publications from the Maine Forest Service. Scroll down past silvicultural activities to stumpage reports. Released for 2019 is our closest date. Here we are, our PDF download 2019 stumpage prices by Maine county or unit. And here's a variety of definitions here. Scrolling. Here's a summary or average for all counties, but we are in Aroostook, so scroll down once more. So we have a volume of saw logs, and that was sugar maple and yellow birch. So 274, 227. Let's ballpark average that. I was going to say 250 and then decided to do the actual math, and it's 250.5. So let's just go ahead with that 250 figure. And let's see, back to our calculator, shouldn't have closed that. 250 times 191,000 board feet. So we have $250 per 1,000 board feet, average for those two species. And we had 191,000 board feet. Gives us $47,750. That is well more than it costs to install our road, which was about $8,000. But we are doing a shelterwood operation, not a clear cut, and let's say we remove half of the volume, or let's actually say we remove 40% of it. So times 0.4, that's a reasonable amount. So we're getting out $19,100 off those 12.5 acres. Back to the GIS. So we are building a road from there to there. Let's go ahead and make that stand out there. So we have a nice red road, as one does. Make that nice and visible. So within this area here, we have about $19,000 worth of wood to bring out, and we have a road that's going to cost about $8,000. That is only considering the volume of wood to be cut off of this area, and only assuming that we're doing a shelterwood operation. Other factors to consider in terms of practicality is that we are going to eventually go in and do the second stage of a shelterwood, which is the overstory removal, which means once these seedlings are well established and have full control over the site, meaning no shade-intolerant species will come in and win the day if given the chance, then you remove the older cohort, and then the new generation takes over. So that's when you cut the other $25,000-ish worth of wood. Building or repairing this road also gives you easy access to all of this area. So what's a $19,000 operation here? This all looks like about the same condition, can be considered the same stand. That becomes maybe a $60,000 shelterwood initiation cut, or shelterwood establishment cut, depending on which silviculture person you're talking to. So what do we need from all of this? We need maps. So we need a map showing the air photo, because that's relevant. We need a map showing the hillshade and, of course, elevation tinted hillshade. Upon the face of each map, we need to know the value of the wood that we are accessing by the building of the road, the length of the road, the estimated cost of the road, and why do I want both of those things? If we're estimating the cost based on the length, why do I also want to report the length? Well, maybe the costs change. Materials costs increase, or maybe you find materials on the road and that reduces your cost. Maybe you change contractors for road building, they have a new quote. Better to just have the length of the road listed so that if you need to refer to it later, you have it right there. So the map should make clear the cost, the benefit, the reasons why we're doing what we're doing. So anybody picking up this map, picture making the map for Jeff Dubas. He's your road building professor, among many other things, department coordinator. So he should be able to pick this map up, read it, know exactly what you're doing and why, and what the cost benefit of this construction would be. And of course the usual scale bar, north arrow, and descriptive title. And if you have a situation like this, where you're doing math for this area that you can't reach with this 1,250 foot skidding distance, but you're also building a road that's going to make it practical to work in this area as well, that's the kind of thing you would include as a note on the face of the map using more additional text. So two maps can have the same text, the same title, the same north arrow and scale bar and everything else, but one should show the elevation tinted hillshade and the other should show the air photo because both of those things are relevant to the construction. With enough detail that somebody who doesn't know this assignment should see exactly what's going on.